Welcome to the GOTO Podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello, everyone. My name is Christian Romney, and I am a Director of Engineering at Nubank in the Flexible Engineering Alliance. And today it's my distinct pleasure to bring to you my friend and mentor of many years now, Russ Olsen. Russ, say a few words to introduce yourself to our viewers.
Hey, well, thanks, Christian. I'm Russ Olsen. I am also a Director of Software Engineering at Nubank. And in my spare time, I've written a few programming books, most recently Getting Clojure. I wrote Eloquent Ruby many years ago. I do a fair bit of conference speaking when the world is a little more normal, or at least I did when it was. And it is great to be here.
Yeah, it is. This is going to be fun today. All right. So, Russ, we're here to talk about functional programming today. I guess that would be the perfect icebreaker. Why don't you tell us, let's level set. What exactly is functional programming?
Functional programming. It's funny if you look on the internet and you Google or something, functional programming, you get all of this sort of mysterious, almost Zen-like statements about how it changes everything. And it's this, I think it has this perception of being this like mysterious, almost, philosophical approach to programming. Fundamentally, functional programming is a different way of looking at programming that makes building programs a bit simpler. It doesn't solve all of your problems. It makes some of your problems easier to deal with. It makes your programs a little easier to understand. And if I sound like I'm trying to undersell it, I'm really not. What I'm trying to do is sort of take away the mystery and the darkness of it. Functional programming is fundamentally this idea. If you are an object-oriented programmer, you tend to take for granted things like classes and inheritance and methods and fields and all that kind of stuff. Functional programming is the idea that you can essentially replace all of that with a few simple tools, a few simple programming tools. So it doesn't change everything about your the way you code. It changes a lot of things, but fundamentally, it is the idea that one way to look at it is that it is the idea that you can take a lot of the complicated machinery that you might be using if you're an object-oriented programmer and replace it with some simpler things, which I think every programmer knows. You make it simpler and the code is easier to understand and all of that kind of stuff.
So I think it's a good segue into the next question I have for you. I think you're beginning to highlight some of the advantages of functional programming, but maybe explore that a little bit. What do you think the advantages of programming in the functional styles are for you?
Well, so back up and talk about what the tools of functional programming are. Okay.
Sure.
And the first tool of functional programming are these things we call pure functions, which always, it sounds like it's sort of a good, bad, kind of evil, dark side, light side kind of thing. My functions are pure. Pure function is a function that just computes something from its arguments and returns a result. That's it, right? So every programmer since day one has been dealing with pure functions, things like all of the math functions. Absolute value is a pure function. You can think of addition as a pure function, right? It takes two arguments, the two numbers you're adding together, and produces a result. And the key thing with pure functions is that they don't perpetrate any side effects. A pure function doesn't read from a file. It doesn't write to a file. It doesn't update a database. It just takes its arguments and computes a result and returns that result. And critically, for any given set of arguments, it always returns the same result. So it's like one of those reliable, easy to understand functions that every programmer knows about. Nobody sort of worries, writes extensive unit tests for the cosine function, right? Someone wrote that thing, tested it once, and we're done. And I think if you could imagine a world where most of your program was written in pure functions, I think that any programmer who's ever wrestled with what state is my database in, do I have the right information in the files, is that global variable or somehow that global state in my program the right thing, would be able to see that if I had a program full of pure functions, it would be easier to test and easier to understand. I just, I send it some arguments, it gives me a result. If I build a test around that, I know that for any set of arguments, it's always going to give me the same result. So programs full of pure functions are just, I think they're sort of mathematical proofs that they tend to be simpler. But just intuitively, if I don't have to worry about global state, and I don't have to worry about the state of the database and the state of anything outside of the code inside this function, that'll make the program easier to understand. And the whole rest of functional programming is, how do I build interesting programs that do useful things with more or less only, not quite only, but more or less mostly pure functions. And that fundamentally is it. I don't think most programmers need a lot of convincing that if they could write their programs with mostly pure functions, the programs would be easier to understand. The question is, how the heck do I do that? And that's what the rest of functional programming is about.
Yeah, so let's go there. You talked about pure logic, pure functions. And said, well, if I don't have to worry about a file or a database, and this is a common thing that most interesting programs have to do.
Yeah.
So describe then. So what's the next step in the process? How do I begin to incorporate some of those things?
So so it's like another one of those sort of misconceptions about functional programming that floats around is that functional programming is all about getting rid of side effects. And that's true, right? Like a pure function, I said it doesn't, but it's also not true because, as you say, all of the useful things a real program does, they're all side effects, right? In the end, I need to write the file, update the screen, hit the web service, put a row in the database, whatever it is you're trying to do. Chances are they're 100% that it's a side effect because nobody can see what's going on inside the program. The idea of functional programming is, we're in the business of producing side effects, but we should not use side effects as the tools to do our work. It's sort of the end result. And the reason you do that is that side effects sort of are like, something sticky on the road or the table or something. It makes things more difficult. It makes everything messy. So yes, perpetrate the side effects that are necessary, but don't use them as a tool. So a typical functional program has some side effect at the beginning. Maybe it reads something from a file or inputs a request, and that's, a side effect, sure. And at the end, it produces some result. Maybe it updates a database or updates a screen or something. And then in between, we try to have as few side effects as we possibly can in the middle of the program because we're trying to avoid, we're trying to get the side effects down to the absolute minimum, which ideally would be the thing that came in and the thing that's going out.
Interesting. So you mentioned a moment ago also that, there's this misconception. What other misconceptions do you feel are out there about functional programming that you'd like to dispel?
Yeah. So the main one is that it's this like Zen, like you got to go to the functional programming monastery and study for half a lifetime before you can really get it. Yes, exactly. And I think there are two sources of sort of the misconceptions about functional programming, and one is completely understandable. It is that people, when you get the idea of functional programming, it's really exciting. I can remember the moment I was like sitting in front of my screen with my keyboard under my fingers, and it hit me. I don't need all of this stuff. I don't need classes and methods and friend functions and private and protected methods and all the rest of it. I just need functions and closures and first-class functions, just a small set of tools, and I can write all the programs that I need. And that is really exciting. It's like I think of it as like one of the high points of my programming career, except that there's been a lot of high points in my programming career, right? Programming is all about, looking at the world a different way. You have some application and you're struggling, like, how can I make this thing make sense? How can I put this together in some reasonable way? And then at some point it hits you, oh, I need a message bus or something like that. And suddenly, like, all the pieces fall into place and you're like, yes, this is a high point of building this application. Functional programming is like that, right? It's like suddenly you see the world in a different way. And, oh, yeah, that is the way I should do this. So yes, it is exciting. It is different. It does make you look at the world differently. But that's what we as programmers do, right? Like, oh, I'm looking at the world differently. This must be Tuesday, right? And so there's that misconception. I think there's a lot of terminology. A lot of the ideas of functional programming were borrowed from mathematics. The idea of a pure function is, what do they call New York pizza in New York? They call it pizza. And in math, a pure function is just called a function, We bring it over and it's a different kind of function. But there's a lot of terminology that comes from mathematics. So functionals and monads and things like that, which is kind of foreign to most programmers. And I think this is a case where the terminology, when you're a beginner, when you're just trying to absorb functional programming, the terminology does not really help because fundamentally the ideas are pretty simple. Pure function, what do you need to build the functional programming? What are these like simple tools? You need pure functions. That's not terribly exotic. You need to be able to treat your functions as values. So you need to be able to like pass functions in and out of other functions as arguments or as the result. You need to be able to cook up new functions on the fly. So if you've, created inline functions in your code and with closures where the function you're cooking up grabs hold of the data kind of around it. In this version of the function, X is 4. In this other version of the function, X is 7, that kind of thing. And you really need immutable data structures, things like that look like arrays or lists or maps or what have you, that are like their non-functional cousins, but which are immutable. And that really just puts the teeth in the idea that your functions are pure functions, because if you can't change your data structures in place, I kind of know my functions are pure functions because they can't perpetrate at least data structure side effects. You need that. You need some way to make all of that efficient, which is kind of a solved problem. And off you go. And that is the sort of the blinding insight of functional programming. Like, it's Tuesday morning and I'm a programmer, so I'm going to have an insight. The Tuesday morning insight of functional programming is that is all you need, right? Functional programs are full of endless elaborations, and there's libraries and there's things to help you. But at the core, you only need functions, pure functions. You need to be able to treat them as values, and you need some efficient, immutable data structures. and you're done. Ish.
Just to be sure we stir up some controversy, can I get you on the record saying that you don't need to understand category theory to understand functional programming?
You don't need to understand category theory. I will say this. So you and I are both Clojure programmers, and Clojure is a dynamically typed language. And one of the advantages of dynamic typing in functional programming is there's no, you do not have a complex type system by definition interacting with your functional programs in a dynamically typed language. So because you don't have that, there's a whole category of conversations you don't have to have. A lot of the really complex terminology in functional programming comes from the interaction of strong typing with functional programming. And I'm not saying that strong typing is bad. What I am saying is that if you have a strongly typed language and it's got really strong opinions about which types can mix with which other types, and you marry that to functional programming, that is necessarily something you're going to have a conversation about. You're going to need words with. So, my friends who are Haskell programmers do talk about functionals and things like that and monads. My friends like you who are Clojure programmers tend not to, just because there's no strong typing there to have a conversation about. Doesn't mean the Haskell people are wrong. It just means they have something else to talk about and they need words to talk about it with.
Surely. So, all this talk of programming languages reminds me of something. You're a self-described programming language geek. So tell me a little bit about what first got you interested in programming generally and, maybe afterwards functional programming in particular.
I started out my career as a mechanical engineer back in the late Middle Ages, just before the Renaissance, I guess. And it was right around the time that people were starting to use computers for mechanical engineering applications for design. So CAD/CAM was a new thing when I was recently graduated from college. And I rapidly discovered that I was a much better programmer than I was a mechanical engineer, like way better as a programmer than a mechanical engineer. It's remarkable that all my fingers are still attached, I was lucky enough that I got a job with a long defunct computer company, manufactured mainframes company called Control Data. And my particular job, I got to frequently be the only user on computers that at the time cost $2 or $3 million. Just the nature of my work, I was like porting applications and things like that. And it was just so much fun. And, as sort of a mechanical engineer, I just kind of took programming languages as, something that existed in the world, like a rock, right? You find a rock on the ground, it's just there. And at some point, I started wondering, how do these things work? And, started going down the rabbit hole of, the compiler produces assembly code, which is actually a whole different language, which produces machine code, which is a similar but still different language. And the computers that I was using were microcoded. So I started digging into the microcode. And I don't know, programming languages just seemed like, if computers were magic, programming languages were the magic that made the magic go. And, and I've just been endlessly fascinated by, programming languages and then the relationship between programming languages and human languages. I think there's some parallels there. And there's real parallels, I think, between programming language communities and regular communities in the wider human world. It's the interaction of people and technology that is just wonderful.
And what wound up wound up drawing you to, functional programming? Was it just when, a few years back now, it was all the rage and you're like, all right, let's go check this out? Or does your interest predate sort of?
When I started programming, I made myself very unpopular in my first programming project because I indented my code. Okay, so it sort of put yourself back in that world, if you can imagine. And as I went through my career, every step of the way, there always seemed to be some better idea, like, hey, let's indent our code, which was the first one, that made programming easier, made the programs easier to understand. And so I went from arguing with people about whether we should indent our code to arguing with people about whether this object-oriented thing was ever going anywhere. And I will say there were lots of blind alleys. I wasn't always right. I was always like the person looking at the next thing for better or for worse. And at some point, functional programming just seemed to be, there were a lot of smart people that I knew who were saying that this was something we should be looking at. And it did, I will say, functional programming was one of those things that took me a long time to get. And I felt like part of it was because I was reading all of these sort of, it's this Zen-like experience that I've been going on about. And when I finally figured it out, it was both like, this is wonderful and this is way simpler than the internet would have you believe. This is just very straightforward.
I remember one of the difficulties I had making the transition from object-oriented programming to functional programming was like, but what? It's just a function I don't understand. Where are the design patterns and all the other things that I, quote unquote, need in order to, make a good program? It was very liberating to realize that you don't need all of this.
Stuff. I think that is why it is. I think that's the big leap. If you're an object-oriented programmer who, and we really shouldn't even say if you're, describe people as object-oriented programmers, right? We're all sort of software professionals here. We shouldn't be defined by our tools. But if you are used to using object-oriented programming, there's a level of complexity that you expect from your tools. And you just described the experience that I was trying to describe earlier. It's like this moment where you say, I don't need all this. I just don't, and it's a liberating kind of thing. There is work in learning the program in a functional style. You constantly in the beginning find yourself, thinking, I'll just jam 44 in the middle of this array. And then you think, oh no, I've got to figure out a way to return something. But again, those are the kind of problems that programmers deal with all the time. Maybe not that exact problem, but it's that, I need to look at this a different way is kind of the definition of what it is to be a programmer.
Yeah. So let's contextualize this a little bit, right? We're talking a little bit abstractly, but let's talk about something concrete. So relate for me, maybe an experience. Think back to your most disastrous programming project and tell me if you had only had functional programming available to you, what would have been different?
There are so many to choose from. In the long view, I'll answer your question in a second, but you just made me realize, I think in the longer view of, going from those days when people argued about indenting code to today, I think one of the things that gets lost is that we are a lot better at this than we used to be. Programming projects still fail at an alarming rate, but nowhere near as badly as they did back in the day, even back 10, 15 years ago. I think we are getting better at it. My most disastrous project, I worked on this document management system that was kind of an OEM product. And we took code from another company that was sort of aimed at a different market. and we would adjust it for the US market and for the industries that we were selling to. And one release, our partners had completely rewritten this big C program into a C++ program. And it, they had great ambitions that was going to make the system easier to deal with, and, all the promises of object-oriented programming. And we got the thing, and we probably spent 8 months and probably $3 million back when $3 million was real money, trying to change this thing just ever so slightly to make it work for our customers in our market. And I just remember the experience was that we were just in the middle of this maze of objects, trying to make sense of the slight differences between the classes. I think of it as object dust, like a badly designed object-oriented program. All of the objects do something, but you're never quite sure what they do or if you have the right object. And I just remember, I think even at the time, I remember, maybe I'm projecting backwards, but I remember thinking, I'm just trying to move this document from this place to this place and put some attributes on it and store it all in a database. Why is this so hard? Well, could you write that system in a functional style? Sure. Could the Russ of the 21st century, second decade, third decade of the 21st century do a better job? Sure. I'm a lot more experienced. But I think it is harder with functional programming to just get lost in the tools, get lost in the infrastructure of your program. Functional programs fundamentally, the idea of the code is you take some data, you transform it, you got some different data now. And I think it's harder to get lost, not impossible. I think it is still possible to write bad code in whatever style and language. If you try hard enough, you absolutely can. Yeah, so I look back on that, and I think if we had been using functional programming, that might have been better. Hard to say over. But thanks for reminding me of that.
That's what we're here for. For me, looking back at there was this one project that you and I had worked on briefly many years ago at a particular cruise line, and they had a reservation system. And I remember this was non-functional programming, but they had some objects that they passed in as parameters. And, then you farm out work to other subroutines in your code, but somebody got the idea to start changing the values that were in the object, which was supposed to be just a parameter, which had things like, the customer's preferences, and it just changed out from under you, like 5 levels down the call stack. Yeah. And, made bugs that we just don't have a certain class of bug in functional programs. We have others to be sure, right? But certainly not that kind. Yeah, I think one of the advantages, I think people talk about this a lot, and it's true. It's certainly not the only advantage of functional programming, but if you're working with immutable data structures, there's a whole class of multi-threaded problems that just go away. Basically, you can never get in the situation where I have a data structure which is kind of in mid-flight. I'm in the middle of making a multi-part change, and I've done 2/3 of it, and then somebody looks at this data structure and it's complete garbage. You tend to just automatically not have those problems. So at least, in Clojure, and I think in most other functional programming languages, you tend not to have like synchronized blocks and things like that. Maybe in very special cases, you just do your thing, and sort of by default, it's thread safe. When was the last time you talked about thread safety in your program? We don't talk about it. It just happens. Yeah, much of the time we get it for free, that's for sure. Yeah. How else would you say it influences the shape or the character of the code that you write?
So on a larger scale, as I say, you tend to have the side effects at the beginning and at the end, whatever the definition of beginning and end is, like when you take an input and when you send out an output, and not in the middle. I think that's one thing. I think the other thing that it does is it tends to make code changes local. Okay. If all your data structures are immutable and you're dealing with pure functions, then if I make a change to this function, it can affect, so the behavior of the function changes. It can certainly affect the callers, the users of that function, right? Maybe I'm returning something different, but it's a very narrow, well-defined. I'll put it to you this way. Let's think about what a good interface is in object-oriented terms, right? Like, I'm going to build an object and it's going to have a great interface. That means that the object is completely opaque inside. I'm not really concerned about what's going on inside the object, right? That's good interface. And then it has, really well-defined inputs and outputs. That is the description of a pure function. Okay. Unless I look at the code, I have no idea what the details are going on inside this function. The only thing I can see is the interface, which is what arguments does it take and what does it send out. And because of that, the experience of working on a functional program is I'm looking at this function and I'm confident that if it really is a pure function and there's nothing untoward going on, nothing unusual going on, then the code that I'm looking at inside that function is pretty well isolated from everything else. And that really is sort of the key to why functional programming makes life simpler for the programmer, because at most of the time I'm looking at some code and the code does exactly what it says it's going to do. And there's very little hidden behind the scenes. There's nobody, if it's a pure function, I can't call something and my argument isn't going to change or, and nothing's going on behind the scenes. It's all kind of right there in front of me. You just reminded me of a war story from my mainframe days, which is, you were talking about passing in an argument and then somewhere maybe deep in the call stack changing something in that argument, and then you're surprised. In my mainframe days, it was possible the constants were stored in writable memory in those like more primitive. And so it was possible to, pass 5 into a function and have somebody change the value of 5, right? So that anytime you had the numeral 5 someplace else, you now had a different. And we would look at that today, right? Any programmer today would say, that's insane. Why is 5 different from a 3-element array or a hash table or any other object you're dealing with, right? Why is the one a surprise and the other one not? In functional programming, they're both surprises, which I think is maybe a more sensible way of looking at it.
The value of values. Certainly. Yeah. All right. So I guess maybe it's time for a parting question, Russ. What advice might you have for programmers out there that are just starting to get into functional programming and want to explore it?
So I think my advice is the same advice I give people who are trying to learn a new programming language, which is, and in a way, functional programming is kind of like, you probably are going to be learning a new programming language, but it's a similar kind of, I'm changing my worldview. And it is find some problem that, is interesting to you, but that you have solved before. Right. So we all have these programs we've written half a dozen times in our career, maybe more, and solve that, write functional code to solve that problem. Okay. And it wants to be something interesting, bigger than hello world, less than, a full blown database or something like that. Find the problem that's sort of medium size that you understand really well, and write a program, a functional program to solve that. And that way you understand the details of the problem, you know exactly where you're going, and you're just trying to look at the problem a different way. I think that is a great way to, learn a new programming style, learn a new programming language.
Yeah, that's great advice. All right. Well, this was a blast for me, Russ.
Well, it's been a pleasure, Christian.
Excellent. And I guess to all our friends out there on the internet, pick up a functional programming language. Hey, pick up a copy of Russ's book. He didn't ask me to say that, but awesome.
All right. Well, thank you, Christian.
Thanks, Russ. Cheers.
Thanks for listening to this episode of the GOTO Podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.